Now in this class you will see turning moment and flywheel. This is also a university problem. It can be asked in Anna University or other universities also. This is the turning moment diagram for a multi-cylinder engine. It is for a multi-cylinder engine. This is torque versus crank angle. This is the torque in the y-axis, crank angle in the x-axis. It is given. It is a multi-cylinder engine. So here the turning moment diagram for a multi-cylinder engine is drawn to a scale. It is drawn to a scale 1 millimeter of torque. Here in the diagram, 1 millimeter equal to 1 millimeter of length is equal to 600 Newton meter of torque. And 1 millimeter equal to 5 degree crank angle. So 1 millimeter equal to 600 Newton meter of torque and 1 millimeter equal to 5 degree crank angle. The intercepted areas between output torque curve and mean resistance line taken in order from one end, from this end, or minus 20 plus 400 minus 270 plus 310 minus 340 plus 260 minus 370 plus 290 minus 260 mm square. So, mean engine speed is 700 rpm. Maximum fluctuation of speed is not to exceed plus or minus 2% of the mean speed. Limiting centrifugal stress is given. Limiting centrifugal stress in the rim is 8 megapascals, 8 MPa. Density of flywheel rim material is 7,200 kilogram per meter cube. This is the density of flywheel rim material, 7,200 kilogram per meter cube. Width of the rim, it is a condition given. Width of the flywheel rim is 5 times the thickness. Find a suitable diameter and a cross section of the flywheel rim. Right. So we have to find the suitable diameter of the flywheel rim. We have to find the cross section of the flywheel rim. That is width of the flywheel rim and the thickness of the flywheel rim. For that we have to find out the maximum fluctuation of energy del E. So here it is given in the diagram. This is 1 millimeter of torque and here it is 1 millimeter of crank angle. It is given 1 millimeter of torque 600 Newton meter, 1 millimeter of crank angle displacement 5 degree, 1 millimeter to 5 degree crank angle, right? So it is given like that. This is here. Now let us assume the energy at A is equal to E. Let energy at A is equal to E. Therefore energy at B is E minus, because it is negative area, positive area, like that it is given, right? So energy at B is E minus 20. Energy at C, E minus 20 plus 400, that is equal to E plus 380. Then energy at D. Energy at D is E plus 380. Here energy at D is E plus 380 minus 270. It becomes E plus 110. Then energy at E. Energy at E here is E plus 110 plus 310. Energy at E is E plus 110 plus 310. Add this. It becomes energy at E. It is equal to 420. Therefore, this is the maximum energy here. Let us see. E plus 420 is the maximum energy. Then energy at F. Energy at F is equal to E plus 420 minus 340. Right? E plus 420 minus 340. Therefore, this is equal to E plus 80. Then energy at G. E plus 80. Energy at E plus 80 plus 260. There plus 260. Therefore, this is E E plus 340. Energy at H is equal to E plus 340 minus 370. Minus 370, this one. Therefore, it is E minus 30. Energy at K. Energy at K. E minus 30 plus 290. It becomes E plus 360. E plus 260. Energy at L is equal to E plus 260 minus 260. This is equal to E. Therefore, energy at L is equal to E. Therefore, here the maximum energy is E plus 420. Minimum energy is E minus 380. E minus 380 is the E minus 30. E minus 30 is the minimum energy, right? E minus 30 is the minimum energy. E plus 420 is the maximum energy. Therefore, maximum fluctuation of energy is maximum fluctuation of energy del is equal to maximum energy minus minimum energy. Therefore, del is equal to maximum energy E plus 420 minus of E. Minimum energy is this one, right? Minimum energy is this one, E minus 320. Therefore, minus of E plus, minus, it becomes plus, that is, it becomes like this, right? E minus of E minus 320, right? Maximum energy minus minimum energy. Therefore, del is equal to 450 mm square. Millimeter square area is given. It is given in area. Therefore, del maximum fluctuation of energy is del is equal to 450 millimeter square. Therefore, what is the equivalent energy in Newton meter? 1 millimeter of torque is equal to 600 Newton meter. It is given 1 millimeter of crank equal to 5 degrees. Therefore, 1 millimeter square is equal to 600 into 5 degree by pi, 5 degree by 180 degrees into pi radian. You have to convert this into radian, into 5 by 180 degree into pi radians. Therefore, del E is equal to maximum fluctuation of energy here according to the given data, right? So, this is 1 millimeter square is equal to 1 millimeter square is equal to 52.33 Newton meter. Therefore, del is equal to 450. Our area 450 for 1 millimeter square, this one for 450 millimeter square, 450 into 52.33. Therefore, del is equal to 23,548.5 Newton meter. So, this is the maximum fluctuation of energy we have found out, right? So, we know that rho, it is given, rho is 7,200 kilogram per meter cube. It is given density of flywheel material. Sigma is 8 MPa, 8 into 10 power 6 Newton per meter square. This is the value given, right? Density. Therefore, mean velocity of the flywheel rim, we know the formulas. Rho sigma is equal to rho v square. Therefore, 8 into 10 power 6 8 megapascals equal to 7200 is rho into V square. Therefore, velocity of the flywheel rim, mean velocity of the flywheel rim V is equal to, it is given 33.33 meters per second. We know that V is equal to pi into dn by 60. This is the formula. Therefore, 33.33 is equal to pi into mean diameter of the flywheel rim d. D is the mean diameter of the flywheel rim. N is 700 rpm. N equal to 700 by 60. Therefore, diameter of the flywheel rim d is equal to, it is given 0.9098 meter. Therefore, diameter equal to, right, 909.8 millimeter is the diameter of the flywheel rim. We have found out the diameter of the flywheel rim. Now, mass of the flywheel rim M is equal to density into area. Density, we know that formula, pi d into A into pi dA, volume into density. Therefore, mass of the flywheel rim, we can find out del E is equal to 2ECS. This is the formula. Coefficient of fluctuation of speed is given omega 1 minus omega 2 by omega equal to plus or minus 2%. Therefore, CS is equal to omega 1 minus omega 2 divided by omega is equal to 4%. Therefore, coefficient of fluctuation of speed is 0.04. Right? We know that del E is equal to 2ECS. E is equal to half mv square, right? So from this we can find out del E is equal to 2 into half mv square CS. Therefore, del E we have found out, right? So this 2 cancels. V we have found out. Therefore, del E value is 23.548 23.548.5 is equal to M into V square, 33.33 whole square into 0.04. Therefore, M is equal to 530 kilograms. This is the mass of the flywheel rim. We have found out the mass of the flywheel rim. M is equal to 530 kilograms. We know that mass of the flywheel rim equal to pi dA rho. Therefore, 530 is equal to pi into dAb into T into rho. B equal to, it is given, width of the flywheel rim is equal to 5 times the thickness. Therefore, we can write 530 is equal to pi into 0.90 diameter 9098 B 5t into T 5t square. 5t square into 7200. Right? From this thickness we can find out thickness of the flywheel rim is 0.07178 meter. Therefore, thickness T is equal to 72 mm. You take millimeter, right? 71.78. Let us take 72 mm, right? Thickness we have found out. Width is equal to 5 times thickness. 5 into 72, right? Therefore, width is equal to 360 mm. So width of the flywheel rim is 360 mm. Thickness, diameter of the flywheel rim already we have found out. This is the answer.